Welcome to the Mr. Beacon podcast. My name is Steve Statler of Statler Consulting, and we've been hearing a lot from people watching the show. Thanks very much for those of you that reached out. Check us out on statlerconsulting.com. You can subscribe there and check out our book, Beacon Technologies, on Amazon. So that's enough of me promoting myself. I'm going to help another company promote themselves in some small way through this podcast. We're talking to Bob Friday of Mist. Bob is the co-founder, I believe, CTO. He was CTO at Cisco, so definitely a heavyweight in the industry. Bob, welcome to the show.
Thank you, Steve. Good to be here.
Yeah, I'm excited to have you because you were right at the nexus of wireless technology, steering the technology at Cisco, and then you left, and you've helped start up this very innovative company. There's a lot of buzz around Mist, so we're going to talk about what the product is, what your customers are doing, and your view of the industry. But first of all, what persuaded you to leave Cisco and help start Mist?
Yeah, hey Steve. I was at Cisco, and what I learned there is I was talking to customers, and we started to have more and more of our what I call our B2C customers. And they said, I was there at Cisco trying to promote something called CMX. Which is really about consumer guest experiences. And when I started talking to these customers, the more I heard about them, the more it was about Bob. Before they were going to put another service on top of their network, they wanted to make sure they could get visibility. They didn't want to put a big bright light on their wireless network with a big mobile app or some new service unless they're going to get guaranteed connectivity. And probably the second thing was really around what I call speed of adoption. They were basically developing mobile experiences. And they really wanted the network, all the location technology, because the network had a key part of that experience. They wanted to make sure the network could keep up with their mobile app development innovation. When I was at Cisco, I did a lot of work on the Meraki acquisition and everything. And the more I looked at this, the more I decided this is really going to require a whole new kind of back-end architecture. So it became a blank sheet of paper problem where, hey, this is easier to do in a startup where you're very focused. When you're trying to build a whole new architecture, it's sometimes easier to do that outside of a big company.
That totally makes sense. So tell us what Mist does.
So we're working on two problems right now. One is what I call Watson for wireless IT. And this is really around trying to help wireless ITs take very vague symptoms, and that kind of related to like doctors, right? When a doctor gets a cancer patient, they get these very vague symptoms. And they basically have tons of data to go through to try to find the answer or the cure for that. Wireless IT guys have kind of a very similar problem, right? When you look at a wireless problem, you usually get a call, you get some very vague symptoms, and then you have terabytes of log files to go through and try to figure out, what is causing the problem. So one of the visions here is really around, can we bring data science, cloud all together to bring kind of this, what I call virtual assistant, that would really help the wireless IT guy get to the problem quicker and faster. And that's kind of related to the other problem we're working on. When we talk about trying to put consumer experiences on top of these networks, you need that visibility. The other issue we're working on is really around, can we bring indoor location on par with GPS? And this is basically leveraging BLE. And, one of the things I've seen in the industry, and this is, I think it's similar to what I saw happen on Wi-Fi 10, 15 years ago, where we saw Wi-Fi was kind of a nice to have. For those who don't remember, it was kind of hard to sell Wi-Fi 10, 15 years ago. You don't think about it today, right? It's like, Wi-Fi is kind of people don't argue about it. But 15 years ago, there were still arguments about whether or not they needed Wi-Fi or not. I see kind of the same thing happening in the indoor location space. Do we really need BLE or indoor location? I think we're starting to see BLE go from what I call nice to have to a must have. And I think there's some friction points that are starting to come down. We finally have a location technology in all our devices. Apple, Google, they've all agreed to BLE. For better or worse, it may not be the greatest location technology, but it solves most of the use cases we need to solve. And probably the other big friction point I've seen with indoor location is really, up to now, it's always required an overlay network, right? They required a separate infrastructure. And when you converge BLE and Wi-Fi together, you overcome that friction point. Now we have a common infrastructure between BLE and Wi-Fi, so it doesn't require a separate budget. So that's what we're working on at Mist, is this wireless for Watson and bringing indoor location on par with outdoor GPS.
Okay, well, it's the location technologies that have caught my eye, but if we have time, I'd like to go back to that Watson thing as well. So you have a device, and I don't know whether you can kind of admit to this publicly, but that is something that is resold, rebadged by Cisco, I believe. They take your product. Is that something you're allowed to talk about or not?
Yeah, that's a public, so Cisco is OEMing our BLE technology. I can actually, I think it's probably fair to say I can kind of show you this is what the inside of it looks like.
Oh, fantastic. I love this stuff. So that is, that looks like you've got multiple antennas in there, multiple radios.
Yeah, so I mean, if you look at what we did, when we started this project, as I said, we really started as kind of, this Watson for wireless IT. What we found, when we talked to some of the retailers, is they were doing these beacon projects, right? They were basically deploying a bunch of beacons for customer engagement and consumer experience stuff. But what they didn't like is they didn't like the fact that every time they rearranged the store or they changed their marketing program, they basically had to move all these battery beacons around. Mm-hmm. So they kind of asked us to do, said, well, can you virtualize this beacon function? And that's what we kind of did, a combination of an SDK, this array, and some back-end software in the cloud. We were basically be able to take that battery beacon function and virtualize it and put it in the cloud.
So let's make sure we've really nailed this clearly, because virtual beacons, I think, is a great idea. And to give you, a practical example, I've, been working with, I love airports because lots of people flow through them. So it's a great place to deploy technology. And we put beacons out at San Diego International Airport, advertising a very obscure website, selling something that most people don't know about and don't care about, which is carbon offsets. And what we found was the website traffic just completely went through the roof when we put beacons out that were pushing out physical web IDs, driving people to the site. So 55% of the web traffic now comes from beacons, which is fantastic. And we think we can raise that. But they're attached to signs. Those signs are going to get moved around. And I'm now thinking, oh my God, all my beacons are going to get lost. How am I going to find these beacons? They're going to get in some storeroom. They might be thrown away. Who knows? They may be detonated and defused by the TSA. So I think that's one of the problems that what you solve, because these things get attached to the ceiling along with the Wi-Fi infrastructure. And then it doesn't matter if there's a reset of the store. It doesn't matter if the shelving and displays get moved around. You can just go to a console. You can point and click and decide where your virtual iBeacons are. Is that a reasonable kind of summary of what virtual beacons achieve?
Yeah, no, I think that's a pretty clear thing. When you look at our user interface, from an IT perspective or from really a mobile app development perspective, you can't tell the difference between a real, one of these beacons, right, mm-hmm. and a virtual beacon. The interface looks like the same. There's a UID, there's a major minor. So from the mobile app programmer, if they've already written a program for iBeacons, it's not the difference. And from the back-end point of view, they can basically move these little virtual beacons anywhere in the floor plan where they have this BLE infrastructure installed. And I think, as I said, you converge this with Wi-Fi, pretty soon you've got a BLE Wi-Fi connectivity solution that solves both your indoor location problem and your Wi-Fi connectivity problem.
Well, it looks like you took a Stanley knife to that Estimote beacon to change the battery. And I guess one of your selling points would be you don't need to do that in that case. Although I have to say, I think the latest generation of Estimote beacons has got really excellent battery life. And that's less of an issue. But I'm sure it's still appealing to people that they don't have to worry about beacon battery life.
Yeah, I think you talked to me. I've talked to several partners who actually, they deploy these beacons either at airports or at stadiums right now, mm-hmm. Or even at the hospitals, right? And pretty much they have it dedicated, like in the stadiums. They're basically have people flying around the country right now replacing those beacons, mm-hmm. and that's that adds up to probably a couple $100,000 a year to have these people flying around keeping this beacon program, battery program in place. Hospitals, same thing. They basically have one guy dedicated running around trying to keep all the batteries updated.
Now, let's talk about what some of the compromises would be. So people buy the benefit of this virtualization, the fact that you can point and click and move around. You don't have to worry about maintaining and so forth. you've got to put some extra effort into deploying these. What would you call them, antennas or receivers, access points? What do you call the device?
You want to get an actual unit. I mean, so when you actually look at the finished product, so this is what they look like, right?
Yeah.
So what does that look like? What does that remind you of?
It looks like a Wi-Fi access point. I'll be straight now.
Yeah, so that's what they look like. So that's the point to say, if we're going to be deploying Wi-Fi, so this is already part of the budget.
Yeah.
People already know how to deploy these and maintain and manage them.
Mm-hmm.
BLE, the BLE array that we put inside of this thing here, once you converge this together, you're already part of an ecosystem that's in place, right? Okay. And that's what takes care of that overlay network problem, right? It does require cable pulls. And you're right. I think what we find is that usually people start with the battery beacon because this is simple and easy. You really don't need IT approval or anything. Any marketing guy can go stick these up wherever he wants to get his mobile app working.
Yeah.
But eventually you have to get to the IT department who actually maintains and runs this stuff. And that's where they start to want this more enterprise grade manageable solution.
So you're kind of positioning yourself for this early majority when the technology department finally figure out what these crazy marketing people have done, and they say, hey, we need to manage this. So I want to get into how the technology works. It's fascinating, and all those multiple antennas. This virtualization only works if you've got something that is more accurate than a regular kind of standalone beacon, because otherwise you'd be pointing and clicking and it would be some kind of amorphous thing. It wouldn't work. So you're achieving more accuracy with your MIST devices. How do you do that? And why do you have 8? Is it 8 radios in that thing? Well, it's actually probably more than 8, but 8 Bluetooth radios.
Yeah, so the array basically has 8 beams. And I'd say there's 2 main things here, 2 fundamental reasons why this really provides better location accuracy. One is when you have a PoE array, we are sending a lot more information, because I don't have a battery to worry about. This battery beacon, typically for battery life, sends maybe 1 beacon a second if you're lucky. The arrays can send up to 40 or 50 beacons per second. So you have a lot more information to actually average.
Okay. So you can transmit a lot faster without worrying about battery life because it's all wired into the grid ultimately over power over. You said PoE, power over Ethernet for marketing people or those of us who have bad memories, which I would count myself as one. So you're broadcasting very rapidly and there's no compromise necessary there. And you have 8 beams and they're kind of radiating out. And presumably my phone is seeing potentially 8 beams. One's really strong and then maybe 2 are less strong. Is that basically, is the phone smart and figuring that out and then seeing maybe beams from another one? How does the poor phone know where it is?
Yeah, so the beams are probably, this is something, 10, 15 years ago at Airspace when I was working on a Wi-Fi location. This is this is unsupervised machine learning. So the other key piece of the puzzle here is when you're doing these RSSI-based location methods, you have to know this path loss model, right? You need to know the relationship between the RSSI and the distance. And that model changes for every different phone. Every different device has a slightly different model. So the other key to getting better accuracy is being able to do unsupervised machine learning. Mm-hmm. And those beams, are a key part of making that work. So you can kind of think of each beam voting on where you're at. Mm-hmm. So if you have, let's say, 2 or 3 of these arrays, you may have anywhere from 16 to 24 different beams voting on where you are in space. Mm-hmm. Each one of those beams are getting turned into a probability surfaces. So basically there's a probability where you are. I have 24 different votes on where I think you are. Those probability surfaces are what key to letting me basically learn what the path loss model for each different model device inside the space.
And so you're talking about path loss, and this is, we may be getting into the weeds here, but, and we talk about it in my book, the fact that with a beacon, it's pretty good at seeing kind of rough distances when you're close to the beacon. As your phone, your phone can tell the difference between 3 feet and 10 feet quite well, but it can't tell the difference between 30 feet and 35 feet or 36 feet. It's just because it's a curve, isn't it? It kind of goes down. And you're saying that you solve that because you basically have a lot more inputs. And there's some machine learning, which I always get very suspicious about when people say machine learning, because I don't know how is it happening, but where is that machine learning going on, and what's it doing? It's unsupervised, so we don't need to worry about it. It just takes care of itself. But tell us a bit more about what that means.
Yeah, so I think what that means in basic terms, right? I mean, so you have this phone here, right? And so it's basically capturing all these beacons.
Mm-hmm.
And that's what's key. Like if you're doing wayfinding, someone's walking down a room or an aisle or somewhere, right? You need to get enough information to make a good average. So every second someone's moving a meter. If I only gave you one beacon, right, one piece of information, you'd have a very hard time trying to figure out where that person is if I just gave you one RSSI. Mm-hmm. So when you actually get the machine learning, this phone here is basically sending back information every second back to Amazon, mm-hmm. where you basically have unlimited compute and storage to do what you want with. Mm-hmm. Once all that information gets back to Amazon, there's an algorithm back there that takes all those probability surfaces and calculates that calculates for this particular phone the relationship between RSSI and distance.
Okay.
And that's your path loss thing.
And that's the name of the company, Mist. It's all kind of cloud type reference. So that's, I assume.
Cloud grounded in reality, Steve. This is
okay. Fantastic. Okay, so it's more accurate. And I think what we're I think we've been talking about two use cases here. One is navigation, which is less about iBeacon packets waking up apps that have been exited or in the background. And the other one is I've got my retailer app in the foreground. I'm in big box store and I'm trying to find where the heck the widget is that I need to buy. So I'm not sure but those are quite distinct use cases, aren't they? Sending an alert to someone, waking up the phone, and the other one is finding their way to the right place to buy something. Is that true?
Yeah, I think there's two fundamental use cases, and this is why people are looking into these arrays now, because they do both of them right. There's kind of the use case where I'm transmitting beacons down, and there's something catching those beacons, and that typically is a mobile app. There's some mobile app catching those beacons. It's usually tied to wayfinding or proximity notification type of use cases. The other major use case is really about listening.
Okay.
And that's another thing we found is compared to the battery beacons, the array can actually listen to things also.
Can you do it both at the same time? Can you broadcast and you can listen at the same time? Okay. So why would you want to listen?
So on the listen side, you have kind of what I call the workflow optimization, and this is around asset visibility. So if you're in the healthcare industry, healthcare is probably a prime example of where they want to do both wayfinding for their customers coming into the hospital, trying to help patients get to the doctor office, but they also want to be able to listen to assets, right? They want to be able to track where that fusion pump is. You see it also in manufacturing, where they want to be able to help people get around the manufacturing floor, but they also want to keep track of assets that are moving around the manufacturing floor.
All right. So maybe the last technical-ish question, how accurate is accurate? How accurate can you get in terms of figuring out, and I still maintain the wayfinding is slightly different to kind of proximity alerts, where you're both the kind of on the outbound side, but what sort of accuracy can I expect to get?
Yeah, so I would say wayfinding and proximity actually go together. We have hospitality customers right now that are putting these arrays about every 15 meters up and down hallways. And at that type of spacing right now, we're getting about 3-meter accuracy for what we call virtual beacon notification. Mm-hmm. So as people walk up and down the hallways, you want to get enough accuracy if you want to put like a bubble somewhere, right? You want to put a virtual beacon somewhere in that hallway to help people understand what's around them. If you're at theme parks, we also have theme park customers where you have the big lines, right? They want to get enough accuracy where they can basically tell you what the point of interest, where you are in line, what's near you or something. So those type of spacings, we get down to about a 3 meter bubble, the getting accurately placed into that 3 meter bubble. If you want less accuracy, if you're just doing wayfinding, you don't necessarily need that accuracy if you're just trying to get people up and down from point A to point B.
That's very good. Well, tell us who are your customers at this stage?
Some examples are we have a big hospitality customer, Swan and Dolphin, over in Disney, that's using it, and they're using it for two purposes. One is, for their guests, kind of for their mobile app inside of their normal guests. They're also looking at trying to do location-based services, right? They have big conferences and event planners coming in there, and it's same like Wi-Fi. They want to start providing BLE services to the event planners coming in. Healthcare is probably another example. Mission Health.
So BLE services. So I want to be able to see what booth someone is standing at, that kind of thing, or?
Yeah, I think it's the same thing, right? If you go to big events, there's several use cases there. One is, hey, I want to get from point A to point B. I want to be able to help people get to the booths. On the back end, people want to get the analytics of, how are people actually moving around, what zones, what booths are getting visited the most. I've seen a couple of use cases where it's more of the, hey, you're at a big show and you're trying to find your friend. It's kind of the red dot, green dot. I want to find Steve. Steve, I'm over here. I don't know if you've ever gone to HIMSS or these big gigantic. Some of these shows are very big, right? You're trying to figure out where's your buddy.
Yeah. So that social aspect is really, I think, very exciting. So we've got some events and hospitality. What other verticals and customers are you seeing adopting this?
I think the other one is commercial real estate, the malls, right? The malls kind of classic. We have a big mall in Miami, Brickell Mall, that's actually using it right now. And that's kind of the classic, trying to help people get to the retail shops. I think people are also looking at this as the beginnings of a marketing platform, right? Typically when you look behind these systems, you'll find a content management somewhere that's really the marketing platform that's helping getting information down to the guests on site. And you kind of think about it, when you talk to people who are in this business, there's kind of this journey, whether it's in the hospitality space or in the mall space, of the journey from home to destination. And usually most marketing guys have a pretty good way of connecting with you when you're at home, either through email or websites. They tend to lose track of you once you get into the venue. So when I'm working with the marketing departments now, a lot of the discussions around, how do you stay connected with the guest or the consumer while they're on site? Yeah,
very good. And let's just wrap up. But before we do, I'd just be interested in your overall assessment of the Beacon ecosystem and a last technical question. So you're like iBeacon. You're not doing the Eddystone thing, is that?
No, correct? We do all three. We do iBeacon, Eddystone, and AltBeacon. And I mean, that's another advantage of when you get to these PoE arrays, right? There's no really cost factor. We can transmit all three beacons. And when you look at what's going on the handset side, Google and Apple are starting to build in new functionality and features into their OSs to support these beacons. Apple has kind of their lock screen thing. Google and Eddystone have kind of the physical world thing, right? Trying to build the URL into the web browsers.
Very cool. So, so you've got a broad view of the market. What's your sense? You described that kind of the early days, the struggles with Wi-Fi. Where are we in the adoption curve? And any other comments you'd like to make about market maturity?
Yeah, like I said, I think on the market side, the thing that got me excited here on the BLE market is, are we at a tipping point? Probably similar to you, right? I've been working in indoor location for the last 10 or 15 years. I was at Cisco, I was a CTO there, and I thought originally it was going to be, indoor location should just come with our phones, right? When I started to get into it, I found out there's a lot of moving pieces that's stopping indoor location from really becoming a industry standard. I think BLE is going to be one of those things that may be the breaking point for it. Because it's, back in the Wi-Fi days, when Intel put Wi-Fi inside of our laptops, that was kind of the catalyst for the whole moving Wi-Fi from a nice to have to a must have. I see kind of a similar thing going on with BLE. We have BLE in all our devices now. So we have a standard interoperable technology that everybody agrees to as kind of a proximity location technology. Mm-hmm. So I think we're there in the ecosystem of that happening. We have the BLE, and that drives down BLE chip cost, right? And that's what happened with Wi-Fi. Once you could break that, we started getting very low cost BLE technology to go in devices.
Yeah.
The beacon ecosystem, I don't know, there must be like 40 or 50. How many vendors do you think out there are making beacons now? I think we're starting to reach critical mass on the beacon.
The beacon ecosystem, golly, I should know this. 380 companies registered in what used to be called Proxbook, the proximity directory. They're not all making beacons, but there's a lot of beacons there. We don't need more hardware. We need more solutions. But I think anyone who can optimize operational issues is going to be welcomed as we move from early adopters to kind of the early majority.
And as I said before, I think the other big hurdle to this thing has been the overlay network problem. Indoor location has always been associated with an overlay network. In BLE now, we're basically converging that BLE with Wi-Fi. So that kind of eliminates the friction point around the overlay network problem. And I think, probably the industry I've seen the most looking to BLE adoption initially is probably in the healthcare industry. Mm-hmm. Because there they have a very strong history of RTLS, right? There's been a lot of RTLS in that industry.
Wi-Fi beacons, right? There's Stanley Healthcare and so forth. But those things tend to have not great battery life. Am I talking out of school? Is that not?
I think that's, healthcare is kind of a great example of where they've had vertical indoor location, right? They've had Stanley Healthcare, WarePoint, Syntrack, and they're looking to BLE as kind of moving to this horizontal standards-based solution, right? Where there's an ecosystem of beacon players, there's an ecosystem of BLE infrastructure players, and an ecosystem of business logic players that go on top of this standards-based solution.
And I absolutely agree. And we saw the first wave was big events, stadiums, sports stadiums, and other like airports is really big. But I agree. I think healthcare seems to be increasingly where people are focusing. And it's where this nexus of engaging with the public and giving them great benefits like being able to check in without getting in line in the crowded doctor's studio and finding the appointment. And then you have asset tracking, which to me, that's one of the trends of 2017 is asset tracking, because the ROI is just a lot easier to track. If you're tracking pallets, there's operational efficiencies in factories. There's I don't have to buy so much expensive equipment if I know where it is in a hotel, so in a hospital rather. So I think that's super exciting, and I'm seeing that from my clients. I've decided one of the areas I'm going to focus on, probably the area, is manufacturing, and we're talking offline about exactly that with one of my clients. The other thing that I see, and I think is going to probably be as big as iBeacon, and it's going to be as big as Eddystone, is NEAD, National Emergency Address Database, 911, and it's a dream project for me. I'm working on it. And it's being driven by something that the carriers have to do. So they're all the major phone carriers are behind it. And this is basically a project to make your phone Bluetooth beacon aware when you dial 911. And that means rather than a kind of dodgy, inaccurate location that goes to the call centers, we'll get dispatchable addresses that are more accurate, and we're going to get floor level accuracy, which can save lives. And so just as someone who's getting on and my friends are getting on, then I want that 911 call to be responded to quickly. And so I think there's going to be an obligation, kind of a genuine desire to help guests and make sure they don't die on premises. And then there's going to be, and we don't want the legal liability, and that's going to translate into lower insurance rates if you have a beacon infrastructure that allows 911 to work better in your facility. And it's just starting to get going. We're getting the standards going. We should talk about this offline, actually, what MIST can do as part of that. But I think, I see a future where one of the reasons why people buy beacons is just to get the infrastructure in place. It'll be like smoke alarms. Then once you've got the smoke alarms in there, actually I can make money out of it. I can improve the customer experience. So I think that's going to be huge. So
I'll join you in the 911. I mean, at Cisco, I was working on the 911. And as you know, right?
You guys are part of it, yeah. On the Wi-Fi, it's not just beacons; it's Wi-Fi as well. To be fair, but beacons have an important place to play in terms of spreading it further at a lower cost with more accuracy. So,
I think indoor location, right? I mean, getting the 911 system to start ingesting other location sources, especially indoor location source. But that was an effort at Cisco we worked on. That's a whole back-end effort, getting the 911 system to be able to take input from other sources, other media sources besides just the phone system.
Yeah, it's happening. It's happening.
It should happen.
Very good. Well, Bob Friday, Mist, really exciting technology, very innovative, and it's been great to hear about your customers and your view on the industry. Really appreciate it.
Okay. Thanks, Steve. Look forward to meeting you.
Yeah. So imagine you're on a rocket ship to Mars, and for some bizarre reason, you can only take 3 songs with you. What would be your 3 songs, Bob?
Well, so that's an easy question right now because I'm in the process of trying to learn to play guitar.
Oh, okay.
So it's Take It Easy by Eagles, Blackbird by the Beatles, and I Know You're Right by the Grateful Dead.
Okay, very good. Well, thanks for that.